how to write a scientific paper. I don't know, I assume that most of you are master students, right? How many of you have written a scientific paper before? No one, one, two, few. All right. So, what is the difference between like when you're in college and you're writing a report for a class project? What is the difference between that and a scientific paper? I know that it might sound like a dumb question. You might say, well, a scientific paper is more complicated, there's more math, but there's a fundamental difference. Does anyone know? So one main difference is that when you're writing a report for a class project, usually a professor tells you you have to implement method X, and you just do that, right? So everybody already knows in advance that that's going to work. If you implement everything correctly, it should work, right? And a scientific paper, by definition, you're proposing something new that in principle nobody knows about. Like if people already knew about this, it would not be a scientific paper. You're proposing, by definition, you're introducing something new. So there's a big difference. This is like you're writing a thing, there's the teacher helping you along the way. And a scientific paper is like it involves pain, and it's difficult because you're going to write something and all your peers are going to be judging you whether you wrote something very stupid. And they may laugh at you, like this guy's laughing at Einstein. So it's different, right? So the main question is, what is the goal of a scientific paper? Well, to understand that, we really need to understand what science is. And I found this tweet. This was from last year's April 1st. I don't know if in Norway you have the same thing where April 1st you tell like practical jokes. So anyway, the tweet was like, this is the only time of the year that when you read something, you just assume that everything is a lie. But in principle, ideally, you should continue doing that every single day of your life. You should like be skeptical about stuff. Right? And that's sort of how science works. It doesn't mean that you have to be paranoid and insane, like Jim told me there's coffee and I'm just going to say, no, show me the evidence. But being skeptical is good, and that's sort of what science is. It's about being skeptical, right? When we try to understand how the world works and how do we solve new problems. The idea is that we don't need to believe in other scientists. That's not how science works. It's not a matter of faith. It's your duty as a scientist to convince other scientists that the thing that you're proposing, your new idea, makes sense, and that they don't have to believe you. If they want, in principle, they should be able to reproduce your findings. And scientific papers are the way that we do this. The way that we convince other scientists that the stuff that you created is awesome and it works in some situations, maybe not in every possible situation. And that we give them all the data so that if they want to make sure that we're not lying, well, not lying, but that our results are correct, they can do that. Right? So a scientific paper, for those who have never seen one, it looks like this. It's like a very specific type of template that everybody uses. There's no particular reason why it's like this, but it looks like that, right? So why do we write scientific papers? The idea is that like this is something that you have to keep in mind all the time. You're proposing an idea to solve a problem. That it might sound obvious, but it's not. Depending on the papers that you read, like the person has no idea what they're doing. So how do you do this? Well, basically the paper is a way of trying to convince other people. It's not a report. You're trying to convince other people that the stuff that you created makes sense and it's important and it works. How do you do this? Well, to convince other people about what? First, that the problem is relevant. Again, I know that most of this stuff, it might sound obvious, but it's not. So, for example, how do you convince someone that the problem that you're trying to solve makes sense and it's relevant, at least to one person in the universe, right? It doesn't have to be relevant to everyone. I don't know if you guys ever read anything on this website. It's like Ig Nobel Prizes. They collect all the research problems like that became papers that are completely irrelevant. So there's like this guy won the prize in 2017. He wrote a paper studying the movement of coffee when you're holding like a coffee cup and you're walking backwards. And he was trying to demonstrate that it's more likely that you're going to spill the coffee if you're walking backwards. Which makes sense, like because you have no idea where you're going. And then he came up with this complicated way of measuring this with many people and many different types of coffee. It's completely irrelevant, but it is a paper, right? So you can do this, but you should not be doing this, or, I mean, it's not very important. So this is the first thing that you have to convince people about. The second thing that you have to convince people is that the problem has not been solved. And this, again, this is something that people often oversee when you're writing your first scientific paper. It's not clear for the reader that you're, like, we already know sort of how to do classification, for example, for you who already study a little bit of AI. There are different ways of doing that. Maybe it doesn't work perfectly always, but usually it works well. So when you write a paper, you have to be careful to convince people that the problem that you're trying to solve, maybe other people already know about this problem, and maybe you can do a little bit better. But it's very unlikely that you're going to propose something completely new. Like, I'm going to present a paper, nobody in the world thought about this, and I'm the first person that is tackling that. That's very unlikely. So you have to convince the reader by listing, like, person A, they tried to do this to solve this problem. It doesn't work always. Person B tried something else, it doesn't work always. And I'm going to address those specific cases where A and B don't work yet. And the third thing that you have to do in order to convince people is that you really did it, right? It's not just saying I'm going to solve the problem. You have to convince people that your method actually does solve the problem, or at least partially, and this is important also, and I'm going to talk more about this later. So you found a better way of solving that. And why do I say partially here? Because it's very unlikely that you're going to come up with a solution that solves all the problems in AI, for example. That is going to, well, there's actually a formal proof that that's not possible. But when people write papers, they have this impression that you have to impress the reader and say, this is the best method, it's amazing, it always works. And everybody knows that that's very unlikely. And what happens in practice is, if you're reading a paper that tries to give this impression, that's really bad. Because you see this person, they are not acknowledging the problems that the method probably has. So anyway, this is your goal. Okay, this is what you have to do. Now, what is the usual structure of a scientific paper? Usually it's something like this, right? So you have like a title, of course, the abstract, which is a summary of your paper, introduction, and then these three things are sort of related. You're going to explain what the problem is that you try to solve, your idea on a high level, how it works, and then related work. Like you're going to discuss other people that try to solve the same problem and how yours is different. And then conclusions. Does this mean that your scientific paper has to have exactly this structure? No. If you write something that is not like this, it's not like I'm going to show up magically and scream at you until you change the format of your text. But if you read many good papers, most of them tend to follow something like this. So it's not mandatory, but it sort of makes sense. Alright, so this is an information that I came up with. Okay, this is not scientific. It's out of my own mind. So how long these things should be, and how many readers you should expect to get for each one of these different sections. So title, usually you get 1,000 readers. What does that mean? If you go on Google Scholar or Archive or any of these places that collect papers, it's very likely that at least 1,000 people are going to take a look at the title of your paper. And most of them are going to say, I don't even understand what this is, they're just going to go pass along. Or people that work in your area, some of them might find it relevant, we don't know. But you get a lot of people reading this. Out of these 1,000, maybe 100 are going to think that the title is actually interesting and maybe relevant to their own research, and they're going to read your abstract. So you already lose a lot of people here. And how do you select a title is actually important. There are like ways of coming up with interesting titles. Alright, the abstract. The abstract is just like the summary of your paper, right? This might be the most important part of your paper, if you actually want people to read it. People often focus on describing the details of like the graphs, everything perfectly. That's important too, but the abstract, in my opinion, is more important. It's usually like 4 sentences, so it's short. Maybe 100 people are going to read it. And assuming that everybody thinks the abstract is interesting, they're going to go and read your introduction, which should be short also, maybe around the page. And after people read this, out of these 100, most people are going to, I don't care about this. So maybe out of these, you're going to get 10 people that continue reading your paper, right? And then if they get to this part, then that's sort of your objective, because this is the first part of your paper where you're actually describing your novel idea to someone. The first part of the paper when someone's actually going to learn something that you proposed. And well, related work, why is there more people reading related work than the sections about your method?
I can only imagine because details are tedious.
That, but it's worse than that. Yeah.
Oh, wow.
Maybe because they want to check if like somebody already done it. If it's
Oh.
worth reading the details about it.
Related to that.
They want to see if it's actually based on something.
That's all assuming that people are not lazy, but yes.
Yeah, no, they want to read more introductions, so they are looking for the related work where they can read more introductions like they have read on yours, and so they skip your details to find another.
Exactly. So what happens most often, everybody does this, it's not a sin, but sometimes I read this paper and I say, okay, the problem is interesting, but I read the idea of this person and I think it sucks. It doesn't make any sense, I'm just going to ignore this. But the person already read something in the literature and they are aware of other papers. So I can just, instead of like taking all the work of myself having to go and read everything that exists so I can compare my method with everything else, I'm just going to be very lazy and I'm going to see what this guy says exists. And I'm just going to like sort of steal all this summary that this person found out about the existing methods. So it's a very kind of like selfish thing to do, but lots of people read this. And then the conclusions, we don't know. Conclusions people usually don't read because, anyways. So this is the usual structure of a scientific paper. All right. How when you're writing this, you have to think what is the objective of each one of these things. It's related to the 3 points that I mentioned before. What is the goal of the abstract? Well, we have to convince the people that there is an interesting problem to be solved. Why it's interesting. You have to convince that nobody has solved that problem yet completely. So you have to show some evidence, like person A did this, but it doesn't always work. And you have to at least give some hints on how you solved it, at least partially. Same thing for the introduction. Introduction is like a more extended version of the abstract in some sense. And then here is where you actually convince people that you did something, that it's relevant, and so on. So my suggestion is when you're writing these things for the first time, actually, like instead of just like sitting down and typing furiously, just like write bullet points where you try to summarize all these things, and then you expand the bullet points into paragraphs and sentences and so on. But anyway, so this is the perfect. I don't know how many people know PhDcomics.com. Anyways, this is the perfect summary of what a paper should look like. It's supposed to be kind of depressing and sad, but it's very, very real. So it's like this person, she's reading his paper, and she's like, oh, I finally understand this. It's about a problem, and this thing that exists doesn't solve quite yet. Your solution kind of solves it, but not always, under some assumptions that may not really be realistic. And that's exactly what a paper is. Like 99% of the papers are like that. Which is not a bad thing, but that's how it works. Okay? So this brings us to the first fallacy, that when you're writing your first paper, sometimes there's like a really long time from the time you decide to write the paper until you actually finish writing and you submit it. And why is that? It's because it's like your own child. Like, I want to have this, it has to be perfect. It's going to be my first idea and I'm going to change the world. And that might happen, but usually people think that you need like this fantastic idea to write a paper, and that's awesome if you have that. But even if your idea is not going to cure cancer or do something amazing, that doesn't mean that it's not a paper. Right? A paper is about a novel idea. It doesn't have to be the most perfect idea. So usually you are not Einstein. You might be, but most people are not. So you don't have to have like the most incredible findings to write a paper. Which doesn't mean that your paper should be bad. Alright, so the final goal of the paper, again, is to convey an idea. You have to convince people about something, that the stuff that you're doing is important. How do you do that? It's almost like you're telling a story to the reader. You're trying to convince the reader about something. So you start by saying, well, there's this problem, right, that exists. It's an interesting problem, so it's not bullshit. Like, there's some people care about this, it's not just me. and it's kind of unsolved. We know how to solve it, but not perfectly. And then by this moment, ideally, the reader would think, wow, I really wish I knew how to solve this problem. I don't know. Because if this person already knows how to solve the problem, they're just not going to read anything. Then you say, okay, here's my idea about how to solve this interesting problem, and you present the ideas, data, and again, what do you want out of these paragraphs? You want the reader to think that wow, this is really like a really good idea. This guy is really creative, and it makes sense, and the way that you're describing things is clear. And I'm gonna go back to this again about how to be clear. And finally, you say, okay, so this is what I did, and this is how it compares with the stuff that already exists. This is the structure, right? All right. About the title of the paper, how would you pick a title?
I would say something that describes it, but also would be kind of easy to understand. But that's hard, I guess.
Yeah.
I guess. Yeah.
I'd write the entire paper down and then put the title at the end to see like what it actually turned out and make it kind of clickbaity.
Right, exactly.
You won't believe what.
Something like that.
So yeah, some people, I mean, the idea is that the title has to be clear, right? Some people write titles to impress people, and then they put all these complicated words, like, I don't know, multidimensional manifolds in this. I don't know what that is. So that's not the objective of a title, because remember, lots of people are going to read your title. If they have no idea what this thing is about, they're not going to go on. And this is not like a hypothetical thing. It really happened. Like, I went to a conference, the largest conference in my area last month. So I was attending all the talks in reinforcement learning, which is what I do for like 15 years. And I could understand maybe like 10% of the titles. I have no idea what they were doing. If I actually read the rest of the paper, sure, I could understand it. But the title, like, why? I don't know. People like to use complicated words. That's not what you should do. Lots of people do what he says, which is a good idea. So for example, like this paper, this was on NIPS, which is a big conference. They come up with like this smart words like the exorcist. Not the exorcist, I don't know, the exponential something. Non-parametric, whatever. But it, like, when you read this, it seems, okay, I don't know, I'm going to read this just to see what it's about. But, so it should be clear, and if you can be funny, I'm not saying that this is super funny, but it makes it more likely that people are going to go to your abstract techniques. Alright, so abstract. Again, in my opinion, this is one of the most important parts of your paper. You have to have these sentences. It doesn't have to be just one sentence, but at least these 4 points. First, like the first sentence should be what the problem is. And this should really be what the problem is. Okay, lots of people, if you read the paper, it's about AI is changing the world. Everybody's using machine learning. That's not the problem. This is just, everybody knows about this. It's not new information. So it should be, in this paper we address problem X, period. Right? It should be very clear. Then you should say why this problem is interesting. You should say, well, this problem, if solved, this problem would help us to build robots that can fly, something like that. And then you say, we did something that sort of solves that problem, and what are the conclusions? Like, what follows from your proposal? Okay, so let me give you an example. State the problem. Robots cannot fly. Maybe they can, but not all. I don't know. This is not I didn't think a lot about it. So robots cannot fly. This is the problem. And then you say why this is interesting, why it's important. You say, well, this is a pity because if flying robots existed, maybe they would be helpful to deliver mail. Which again might not be true, but it's one way of trying to convince the person that it's interesting. And then you have to describe very shortly, again, it's like a sentence. What you actually did. What is your contribution? And you can say, well, we propose a method by which a humanoid robot can fly using magic. And what follows from this? And you can say, well, what follows from our contribution is that we are capable of comparing this with 2 other techniques, and we show that ours work better if there's no wind. Okay, so why did I say no wind? Because it's usually good to acknowledge not only like the good things about your method, that it works, but also to make it clear that it's not perfect. Because if you suggest that the thing that you did is perfect, reviewers are going to actively try to find problems in your paper. And I know that because I do that, all reviewers do that. And then you say, what do you expect is going to happen? Well, we expect we're going to change, we're going to allow for faster availability, something like that. So this would be a perfect abstract. Not exactly like this, but that's this version. Right. So introduction. So introduction is like an extended version of this abstract. So again, you should describe the problem, and here you can use more details. You can add references to papers that exist. Then you should state your contributions, just like we did. And I'm going to go over each one of this. And you're going to reinforce all the points that you already discussed in the abstract. So the motivation, why this is important, why this is interesting. Like you have to really convince the person, right? It might sound a little bit redundant, but remember that the goal here is to convey an idea and convince the person that this makes sense. And always use intuitive idea. If you read some introductions, people, like from the beginning, they come up with this complicated math, and that doesn't work. It doesn't work at all. So how do you describe the problem? This is like part of an introduction of a random paper that I found. How do they describe the problem? If you, I like highlighted the sentences, the key sentences, to show you how they described the problem to try to convince the person that the problem is relevant. These are the key sentences. They start by saying, this is really the problem. That, while the deterministic planning the maze, they have this nice property, right? And one of the things that is most used are MDPs, which is like a mathematical model. But then they say this model sucks. Sometimes it doesn't work very well. So even though it should be okay, nobody uses it in some situations because it's hard to do something. So this is the description of the problem. This thing exists, it's not perfect, and it has problems, and so now the reader knows exactly what is the problem that you're trying to solve. They don't know how you're going to solve it, but you know they know for sure that you're going to try to improve on this thing that you just pointed out has problems. Alright, so then state your contributions. Again, you could try to find, you could use math and you say, this is the theorem, that's not what you should do in your introduction. Usually, the way that I try to do this is by actually writing a list, like an enumeration of the contributions that I'm proposing. And for the rest of the paper, this list that you prepared, like my first contribution is A, my second contribution is B, this is going to drive the entire paper. This is going to sort of be the guideline for structuring the rest of your text. Everything that comes afterwards is going to be, how do I convince the reader that I actually achieved contribution number 1 that I listed here? How do I convince the person that I achieved contribution number 2? And so on, right? And this really should be a list. It should not be like all around merged with random parts of the text. You should actually have a sentence. This paper, our contributions are 1, and then you say something, 2, and then you say something. Okay. Then it's completely clear what you did. And ideally, again, the idea would be that readers, after reading this, they say, wow, I don't know if they actually do achieve all of this, but if they do achieve this, this is exciting. That's your goal, right? So again, don't leave the readers guessing what the hell you're trying to do. Write a list. So like this. This is from the same paper. They explicitly say, we do 2 things. A, and then they do something. B, they say the second thing that they propose, right? So bulleted list of contributions. One thing about the contributions, how do you actually explain, so yeah, how do you explain what is a contribution? You could say, well, one of the contributions is that, like one of the things that we do in the paper is we describe the system and the system is really cool. This is not a valid way of describing a contribution. Why? Because everything, like what does it mean to say describe the system? And when you say it's really cool, what does that mean exactly? Like, I don't know. So you should be more precise, right? You should say, what do we mean by describe? We say, well, we give the syntax and the semantics of a language that whatever, and then you should enumerate, like the new features that we're proposing, which is like why it's cool, are X, Y, and Z. Lots of people say like vague things like this. We study the properties of the system. What does that mean? I don't know. you should say, well, we prove that the system works by doing X. And say we have used the system in practice, that's also very vague. What does that mean? You have to say, well, we built this toolkit and we implemented whatever. So the idea is that these contributions, they should be refutable. The reader, if you say the system is cool, how would the reviewer say, no, it's not cool? Right? But if you say something concrete like this, then they can at least decide if they agree with you or not. Alright, so this is the introduction. Now these other sections are all related to actually convincing people that you do achieve the things that you said that you did. So, notice that at the beginning of the talk I mentioned that it's very unlikely that you're going to be creating something that nobody ever thought about before, right? So what some people do, I don't, there's actually a debate. Some people around here, they have a section on related work. Like before describing your contributions, they say something like, okay, now that you agree that this problem is interesting, let me discuss a little bit about what already exists, how other people have tried to solve this problem. And then they have a related work section here. I am completely against, again, it's a matter of style, but if you do it here, it's wrong. Don't do it. So can anyone think about a reason not to have a related work section here?
Because then everyone will just start reading that instead of your problem.
Right.
You just give them an easy exit.
What else? So that's one big thing. Well, you have not yet presented your idea, and now you're sort of like advertising other people's ideas, which is not a bad thing. It's worth, like, it makes sense to like try to educate people about other interesting methods that exist, but that's not the goal of your paper. That's the goal of the other guy's paper. So describing alternative approaches gets in between the reader and, like, remember, the reader is reading your paper because they thought that your idea might be relevant to them. They don't want to read about other stuff. They want to read about your idea. So they get sleepy and they just give up. The second problem is that before you actually describe like the math and you give concrete examples about how you're solving the problem, how would you even describe these other methods? The person doesn't know about any of the techniques that you're proposing. And now you're going to have a section with like many technical terms, and so like it's very likely that the person is going to feel very stupid because they haven't read yet. They haven't gotten to the part of your paper where you actually describe how things work. And you're describing not how your paper works, but how other even more complicated papers work. In my opinion, this is like completely the opposite order that you should do. So instead of doing that, what you should do, the thing decides to cooperate, is to concentrate on like this narrative. Again, it's almost like you're telling a story. You should again describe the problem, why it's interesting, and then describe your idea. This is going to be the place where you're going to describe your method, or how you're combining existing methods, or how you're going to run an experiment, whatever is your idea that you're proposing. And then you're going to defend this idea, because you want to convince the person that it's a valid idea and that it's awesome. So you're going to show how it solves the problem. It solves the problem by computing some number that solves all the problems in the world. And then, so like when you're describing your idea and try to convince the person that it makes sense, in passing, it's okay to cite relevant work. You can say something like, in this work, we use neural networks, and then you cite neural networks. It's okay to acknowledge at this part of the text things that are related. But this is not the place where we're going to discuss those things in detail. Right? So again, if you are sort of not completely sleeping yet, the idea again is over and over again this narrative. Right? You're trying to tell a story and convince people that it makes sense what you're doing. So how do you convey the idea? Well, this is the main thing. This is what I try to do, and all the papers that I really, really like, I notice that they do the same thing. They try to explain the idea as you would explain to a friend if you were using a whiteboard. So like if someone asks, okay, how do you do whatever I'm doing right now? I'm not going to say, well, let X be a random variable and let this be a field over. That's not how you talk to normal people. right? I hope. So that's not what you should do in a paper, at least not here. You should explain things using intuitions, because then the person really understands on like almost like an emotional level why the thing is important. And after they get intuition, then they are going to be able to follow the details much better. If you just start, and the random variable thing is not, I'm not making this up. I went to a talk, and the first thing that the person said, they didn't say hi, they didn't say anything, they said, let X be a random variable. That was the first. So I went out for a drink. So that's not what you should do. And yeah, so like, why is this important? Not only because it helps the person to be able to more easily follow the details later on, but even if this person decides that they don't want to read all the details, at least they know that on a very high level what your idea is. So if they ever work on this same problem, they might cite your paper, right? Because they know what you're trying to do. They don't understand all the details, but they know that your paper is relevant to that area. So one thing that really unrelated to this, but notice that I said like she can follow. It's very important to be gender neutral when you're writing a paper. Well, when you're writing anything, right? So don't make any assumptions. There's so many papers where when you see the person saying, the user did X, he did something. Like you shouldn't assume that it's a man or just. And then there is this discussion how you should do that. Some people say that's what I do. For example, I tend to use they. The user did this. They believe that. But anyway, it's important, right? Then comes the payload of your paper. How do you actually deliver the main ideas? This is how many people try to do it. When they start to describe the main contribution, they come up with sentences like this. Consider I don't even know how to pronounce this, bifurcated semi-lattice D over a hypermodulated signature S. And then, I don't know, I have no idea what this is. Maybe, I mean, this might be relevant to my research, but who knows what the hell this means. So it sounds very impressive, and maybe but I mean, besides making everyone fall to sleep, but what is the conclusion that the reader is going to get from reading something like this?
I'll read something else.
Yeah, I mean, for sure they're going to read something else, but the main conclusion might be, well, this author, he seems very intelligent. He or she, they might be very intelligent, but I can't follow this. And so I'm going to read something else. And they're not going to get the main idea of your paper, which was your goal. So you just failed because you sounded very impressive, but they don't care, right? So this is not, again, how you deliver the payload of your paper. You must provide details, intuitions, and first convey the idea and then actually have math. Right? With examples if possible. All right. Speaking of experiments, how do you present your experiments? So usually, like first you're going to describe the math and so on, but even when you're doing that, don't ever do something like this. Try to give examples. So you should, I mean, I have no idea what this is, but you should say, like, for example, a semi-lattice D could be, and then use, could be a robot. I don't know if it could be a robot, but come up with examples. All right, so after you describe the idea, the algorithm, and you define all the variables, how do you describe the experiment of your paper? Well, usually we do these four things. We describe the setup, which is how you're going to run the experiment. And then you say, well, we put the robot in the middle of the room. It's robot that was built by someone. These are the properties of the robot. And then you say how we apply the method. Well, we run the algorithm on a simulation first, and then we uploaded the behavior that was learning simulation to the robot. The methodology. What is it that you're going to use to actually make sure that this thing is working? Right? You can't just run the robot and the robot runs around. Does it work? I don't know. You need some kind of concrete metric to measure the performance of your robot. It sounds obvious, but many people don't describe exactly what is it that they're trying to optimize. So you should say, our goal here is to minimize the time that it takes for the robot to go around the room or something. You have to be very clear about what this is. And then the results. Well, because almost by definition you're not the first person that is trying to solve this problem, you need to compare with other approaches, right? So you have to implement those approaches, or you have to download an implementation and run it on the same problem. And usually people do two things. They compare with a selected state-of-the-art method, like this other guy published 6 months ago. They published a method that tried to solve exactly the same problem. So I'm going to compare with that person. And baseline methods, which are like not very specialized techniques that work specifically for this problem, but that you could use. It's just like a hack in some sense. All right, so about comparison with other methods. There's something that is very important that gets reviewers very, very mad, which is you add references to all these papers that were relevant to your paper. You say, well, author A, they did something that is related. It's not exactly the same thing that we did. Author B did the same thing. So you acknowledge that lots of things exist, but then you just completely ignore them when you're trying to convince the reader that your thing makes sense. This is the best way of getting your paper rejected. Not the best, there are worse things that you could do, but this is really bad. Okay, so if you cite something and meaning that you agree that the thing is relevant, you should compare with that. And if you cannot compare, you should make it clear why you cannot compare with that. You can't just escape from this, right? Which is the easy way out. You just, I don't have time, just gonna run this. You have to be careful. All right, and then related work, which I said you should postpone to the end. What is another problem that I see in many papers when they're writing related work? Some people, they try to pretend that they're coming up with this completely new idea. Like, I invented this new field. That's very unlikely. It's possible, but it's unlikely. So most of the things are not new. And it's very probable that your work is going to build on the work of other researchers. I'm not going to invent a new field of math, probably. And it's your goal, it's your obligation to try to make the reader understand that there's this bunch of papers trying to solve this problem, and each one of these papers has advantages and disadvantages, and you're going to try to find like the place, the thing that none of these papers really solves, and that's where your paper is going to go. Okay, there might be intersections, but you have to make it clear what is it in the existing literature that has not been solved or has not been completely solved. And that's how you convince the reader that what you're doing is novel enough. Right? So you have to add all the references. Another problem that I see when people writing related work, they believe that to make my work look good, you have to make other people's work look bad. They say, author A did this, but this is completely stupid, and this person, they should be arrested. You should not do this. And the truth is that in papers, in science, usually credit is not like money. If I assign credit to someone, meaning this person did something, it's not like you're losing your own dignity by doing that, right? So it's okay to give credits to others. That's not going to diminish the credit that you may get from your paper. The credit comes from your contributions, not from trying to make others look bad. So warmly acknowledge what people have to. I wouldn't use exactly this type of sentence, like in this inspiring paper, it seems like, I don't know, I think this is too much, but you should say, like, this guy shows a method that has many interesting applications, and they show that it works in situations A, B, C, and D, and that is really cool, but it doesn't yet address problem X, which is the problem that we're trying to address. So you should really try to point out not only the downsides, but the positive aspects also. And still related to this, you should acknowledge the weaknesses of your approach. Whenever I read like an experiment section and everything sounds perfect, I actively start to try to find problems in your paper, because for sure there is. Nobody ever came up with a method that solves all the problems in all situations. It doesn't work. All right, so then conclusions and future work. Conclusions is, again, I think very few people read conclusions. I don't read conclusions because it's almost like a summary. It's almost the abstract with just, instead of saying like we are going to do this, this is like we did this. And future work is, I mean, it's kind of standard, but future work is you just do this because people expect you to do this. Sometimes you're being honest. You're saying, I really want to try this other thing out. But most of the time it's like, I can't stand looking at this anymore, I just want to publish this, and I don't ever want to work on this paper again. But it's standard practice to say, okay, what are the things that still don't work very well? And then you say, well, my future work is to try to address these limitations that I pointed out before. Alright, things to be careful, besides all this stuff that I already mentioned. Run a spell checker. This might sound obvious, but whenever I read a paper and there's all these crazy typos, that's a problem. So for example, this is perfect. This is like a completely valid sentence in English. Do not trust spell checkers to find all mistakes. This is completely right, but no spell checker would catch any of these errors. Print and check for simple typos like "n" instead of "and", or like repeated words. Grammarly, does anyone know about this? This is the best thing that was invented. You go to this website and you upload the text of your paper, and it gives you suggestions on not only how to improve, like how to solve typos and stuff like that, but it gives you style suggestions. Like maybe this sentence is too long, or maybe you should add a comma here. Maybe you should, instead of using this sentence, like this word, like wonderful, you should really not use words like that in a paper. Maybe you replace this with something else. So this is really good. There's a free version of Grammarly. There's a paid version of Grammarly. It's not super expensive. I really believe this is good. And then this last thing, this is a matter of style, but most people try to follow this. Like your text, it doesn't have to be formal, like I'm speaking to a king, right? But don't, usually people avoid using contractions like don't, can't, won't. It's, you say, well, the objective of this paper is, there's no real reason to do this, it just looks better, and maybe it's because how we got you to seeing things. Alright, other problems that I see, graphs. What is this graph showing? It can be anything, right? And there are many papers where, like this graph, there's like a caption here where actually they describe what this thing is, and maybe they discuss the graph in the text, but there are no, like the axes are not labeled, and it might sound like it's not a big deal, but it really makes people mad. It really makes me mad when my students add graphs like this. I auto-complete the axis for them, usually with something like time of the day and number of waffles on the moon. Because if you don't say what this is, I can interpret this in any way that I want. So don't forget axis. This pisses people off. Define everything. This is another problem. So when you come up, like by the time where you have to describe math, name all the functions, say explicitly what are the inputs to the function, the outputs, all the variables, give names to the variables, describe what they are intuitively, describe if they are scalar, number, a vector, a matrix, everything else. So like a well-written description would be this, and I wrote this, so I'm very proud of this. So like the objective of whatever is to maximize this, and then there's an equation. Well, the equation, there's a bunch of letters, right? And I say, well, what is pi of theta? Pi of theta is that. And what is theta? Theta is that. What is tau? Tau is that. Right? So you should describe everything. I hope I did describe everything here. I think I did. Right? Lots of people say, well, I don't need to say P of X. Everybody knows that P of X is a probability. But no, you don't know that. You have to describe things. So you really have to be careful and very precise. How to write well, that's a matter of personal choice. There are a few books like this one by Strunk and White. This is a classic book. It's called The Elements of Style. And many people, when they are starting their master's or like the first postgraduate course, they read books like this. They have really good ideas on how to write more in a way that is easier to follow, and it's really good. And it's very short. It's like 50 pages or so. So I highly recommend this. And just to go back to the thing that I mentioned at the beginning of the talk, one fallacy that people have when they come up with paper writing is that they think your goal in academia is to impress other people, to convince people that I'm smart. That's not the objective. People are going to think that you're smart because they read the paper and they agree that your idea was a really good idea and it works. If you just go to a conference and start to use complicated words, you're just going to sound like a very arrogant person. Like this is Calvin saying like he was doing his homework and he titled his homework "The Dynamics of Interbeing and Monological Imperatives in Dick and Jane: A Study of Psychic Translation of Gender Modes." Doesn't mean anything. It sounds very smart, but it doesn't mean anything. So that's not what you should do in papers, right? So that's the idea. So this is the summary of everything that I said. If you don't remember anything else, remember this. That the idea of a paper is to propose an idea and to convince people. It's about telling a story and convincing people that the problem makes sense, that it has not been completely solved, and that you did at least partially solve it. Right. Okay, thanks. Any questions?
So say you have this awesome idea which you're trying out, and you actually find out that the idea was not especially awesome, or it's no key in your contribution or in your work. Would it still be situations where it would be available to write a paper of it?
In my opinion, yes. And I think that's one of the big problems that we have right now, that most conferences tend to accept only positive results. Like saying, I tried this out and it worked really well. But then let's say you tried 10 other things before that did not work. So only after 10 you did find something that worked. Other people that are trying to solve the problem, they might try all the 10 things that you tried again, because they don't know that it didn't work. So everybody's wasting time trying to reinvent things that someone in the planet know that it's not a good idea. But anyway, it is a problem. I think some conferences are changing the way they work and starting to accept negative results, which are also a valid result. What I try to do is, if I try an idea and it doesn't work well, I usually have a small section saying something like, one possible way that you could try to solve this problem is by doing this. But we actually tried this and it doesn't work for reasons X, Y, and Z. So how can we improve on this? And then you actually go to your... So it's not like a paper completely describing in lots of details why it didn't work, but I think it's important to acknowledge. Any other questions?